Hello everyone, I hope you're doing well. My name is Vasily. In this video, I'm going to present my solution for the tutorial number 6 for the course COM 1406. So first of all, I would like to show the fact how I solved the problem number 1. So if we go to the main application here, so just give me 1 second. I'm gonna fix something in my code. First of all, you can see here that every time we're calling the Fibonacci function, we are storing its result in the integer in the variable of the type long in the variable of the type long. And so therefore this would help us to expand the number of the arguments that we can pass in while returning their correct value, because the long type of the variable uses 64 bits to store the result. And the same thing applies to the Fibonacci. So every time we're calling the Fibonacci function on the argument equal to n, we're going to store the result in the long type of the variable. And so now if I call this function and then if I run the application, and so if I put the range from 1 to 20, you can see now that for the last 3 values in the factorial function, you can see that we're not getting some weird negative values, but rather we're getting the positive values because we're using the long type of the variable to store the result. Okay, and so now if I go back, I want to show how I solved the problem number 2. So in the problem number 2, we were basically asked to observe the runtime for the Fibonacci function as well as the runtime for the factorial function by adding the two dates, so the time when the function starts and the time when the function ends, and then where we're asked to print out the runtime of the function by finding the difference between the end and the start point, and then printing them along with the result of calling this function. And so now if I again run the program, and so if I type, for example, 42 to 46, you can see that for the Fibonacci function it takes quite a few time to calculate, and I assume that these values are shown in the milliseconds, and so therefore in the usual units, like the usual seconds, so you can see that it took approximately 5 seconds to calculate the Fibonacci number for the n value equal to 45, and for 46 I would assume that it was approximately 7.7 seconds to calculate that. I think it was approximately correct, and you can see that it took quite a few time to calculate the Fibonacci numbers using the old Fibonacci function. And so now if I go back into the math utilities class, so here as you can see we were asked to add additional lines of code to create a simple class called Fibonacci result, as well as this static function Fibonacci, sorry, the function called better Fibonacci. And so in this case, these are the optimized versions. And so if we go to the main class, now if I comment out this and then add this lines of code, we would see that using this function would be actually more efficient. And so now you can see here that now we're going to have the math utilities Fibonacci result, and so therefore the variable called Fibonacci I, it's actually going to be of the type Fibonacci result, and we're going to be calling the function math utilities better Fibonacci. And at the same time, when we're going to be printing out the result, we're going to be printing out the Fibonacci current value which is one of the 2 values stored in the variable Fibonacci I. And so now if I call this function and I again put the range from 42 to 46, you would see that now all of the Fibonacci numbers, they were calculated instantaneously. It was very fast in comparison to our previous method. And so I will also show you where we go out of the bounds for the long type of the variable. So you can see I typed the range from 100 to 106, and now you can see that for all of the values up to 103, everything was okay, so the values were positive. But once we reached 103, this was like the key point where the result of calling the Fibonacci function went out of the bounds for the variable of the type long. And so I hope this explains how I solved tutorial number 6. Thank you for your attention, and bye for now.